It's your dear Mr. Samrad. Welcome to chemistry class. We shall be considering acids, bases, and salts. This topic is in series, and so we only focus on acids and bases in this video. At the end of this video, you should be able to classify acids and bases. You'll also be able to state properties and preparation of acid, be able to give uses of bases and acid, you'll be able to test facility and alkalinity and perform simple calculations. What are acids and bases to us in our everyday life? What do you think these products have in common? They contain acids. Acids is gotten from a Latin word which means sour. These products have something in common. They have sharp taste. They are soluble in water, and if the acid in them are extracted and concentrated, they will be corrosive. So, anytime you eat apple, or you drink juice, or you take banana, you are consuming food items that contain acid. What about these products? These products do not contain acid. So, if there is no acid in them, then what they contain will be alkalis. Alkalis are the chemical opposites of acids. They destroy the property of acid by removing its sharp taste. When they are touched, they have a soapy feel. So, when you press your toothpaste and toothbrush and you take your paste with soap, you are making use of base or alkali. Let's go on and see classes of acids. We have organic acids gotten from plants and animals, and they contain carbon. And we have inorganic or mineral acids, which is often gotten from mineral deposits, and they do not contain carbon. Let's look at examples of organic acids. We have tartaric acid present in tomato. Vinegar contains an acid called acetic acid. Grapes have oxalic acid in them. Even your orange contains citric acid. Wait a minute. Do you know formic acid is present in the stink of this, and your lactic acid is in milk? Now, let's look at inorganic acids. These acids are often found in the laboratory. Hydrochloric acid, sulfuric acid, nitric acid, and boric acid. So, let's talk about bases. We have inorganic bases gotten from mineral deposits, and organic bases gotten from plants and animals. So anytime you hear organic acids or organic bases, it means they're gotten from plants and animals. Inorganic acids and inorganic bases are from mineral deposits. Let's now look at examples of inorganic bases. Caustic soda and ammonia, they are inorganic bases, while choline hydroxide and pyridine, they are organic bases. So, now let's look at definitions of acids and bases. These different scientists worked on acids and bases. Antoine Lavoisier in 1777 defined acid as a substance that can contain oxygen, while Humphrey in 1810 defined acids as substances that contain hydrogen. In 1838, Justus von Liebig defined acids as substances that can react with metals to produce hydrogen gas. And this duo in 1923 worked independently to define acid as an hydrogen donor and a base as an hydrogen ion acceptor. So, we're going to define acid according to Arrhenius. An acid is a substance which, when dissolved in water, will produce hydrogen ion as the only positive ion, while a base is a substance which, when dissolved in water, it produces hydroxyl ions as the only negative ion. So, using this formula, AH will give us hydrogen ion plus. So, for instance, hydrogen chloride, when dissolved in water, will give us hydrogen ion plus. So, this is an acid because it gives us hydrogen ion as the only positive ion. But for the base, you can see that this base can only give us hydroxyl ion. So, if for instance sodium hydroxide will give us hydroxyl ions when dissolved in water as the only negative ion, as we can see from here. Now, let's look at some terminologies used in acids and bases. When you hear base, it simply means a substance which will neutralize an acid to produce salt in water only. Example of bases: sodium oxide, potassium oxide, magnesium oxide, sodium hydroxide, potassium hydroxide. While a base can be soluble, some bases are not soluble. Any base that is soluble is considered as alkali. So an alkali is a basic hydroxide which is soluble in water. Take for instance sodium hydroxide, potassium hydroxide, and calcium hydroxide. They are all soluble. For sodium oxide and potassium oxide, as well as magnesium oxide, they are not soluble. So these three, sodium oxide, potassium oxide, and magnesium oxide, they are bases, but they are not alkalis. So copper oxide is a base because it cannot dissolve in water, so it won't be regarded as an alkali. But sodium hydroxide is also a base, but because it can dissolve in water, it is regarded as an alkali. So we can say all alkalis are bases that are soluble, but not all bases are alkalis, because some of them they do not dissolve in water, but they can all react with acids, both bases and alkali. Now at this junction, let's talk about strong acid. A strong acid is the one that will dissociate completely in aqueous solution to produce one or more hydrogen ions. Example of strong acid, we have tetraoxosulfate 6 acid, hydrochloric acid, and trioxonitrate 5 acid. Weak acid, when it dissociates, it does this partially to release hydrogen ion concentration, and its concentration is very low. Example, ethanoic acid, sodium triiosocarbonate 5 acid are weak acids. So let's look at the chemical equation for strong acids. When we make use of sulfuric acid, as you can see, tetraoxosulfate 6 acid or sulfuric acid has 2 hydrogen in its formula, H2SO4, and when it dissociates or breaks down in water, it releases the 2 hydrogen atoms as 2 hydrogen ions. That means it's releasing all its hydrogen ions. But weak acid, for instance ethanoic acid, when it dissociates in water, out of 4 hydrogen atoms it has, only 1 will be released, which is the one attached to oxygen here. So out of 4 it releases only 1. That makes it a weak acid because it's releasing or ionizing partially in aqueous solution. Now, what about strong base or alkali? A strong base is the one that dissociates completely in aqueous solution, and such alkali have high concentration of hydroxyl ions. But look at 1 or 2 examples of this: sodium hydroxide, potassium hydroxide, and calcium hydroxide. They are regarded as strong base. Weak base or alkalis, they dissociate partially in aqueous solution to produce hydroxyl ion. Our ammonia, as well as ammonium hydroxide, and pyridine, they are weak base. So let's use a chemical equation to define strong base. Take for instance sodium hydroxide. When it releases is hydrogen ion. We can see that it releases hydroxyl ion. Sodium hydroxide releases its hydroxyl ions completely in water. That's only one here, and we can see that here. So that makes it a strong base. But ammonia does not have hydroxyl ion at all. So when it dissociates in water, it does this to form ammonium ion, and hydroxyl ion is partially released. This is a weak base. At this junction, we can talk about concentrated acid or base. So when you hear concentrated acid base, it means large amount of acid or alkali is dissolved in little amount of water. So small amount of water added to large amount of acid or large amount of base will give us a concentrated acid or base. Dilute acid or base. When there is little amount of acid or alkalis dissolved in large amount of water. So it means we have large amount of water plus small amount of acid and base. This will give us dilute acid and base. Please note the difference. Basicity of an acid. When we say basicity of an acid, we refer to the number of replaceable hydrogen ions in one molecule of the acid. For instance, tetraoxosulfate 6 acid has 2 hydrogen atoms, and it can dissociate to give us 2 hydrogen ions, which are replaceable. Therefore, the basicity of sulfuric acid is 2 because it gives us 2 hydrogen ions. You can say sulfuric acid is dibasic. Dibasic means 2 basicity. Hydrochloric acid has 1 hydrogen atom. So when it dissociates, it will give us only 1 hydrogen ion. So because it is only 1 hydrogen ion, its basicity is 1. It means that hydrochloric acid is monobasic. Mono means 1. Trioxophosphate 5 acid has 3 hydrogen in its formula. When it dissociates or ionizes, it releases 3 hydrogen ion. So trioxophosphate 5 acid has a basicity of 3 because it will dissociate to give us 3 hydrogen ion, which is then tribasic. But acidity of a base is different from basicity of an acid. What does acidity of a base mean? It means that the number of replaceable hydroxyl ions present in one molecule of that base. Magnesium hydroxide can only produce hydrogen ion. So the basicity is 2 because magnesium hydroxide produces 2 hydroxyl ions. So its acidity is 2. While sodium hydroxide can only release 1 hydroxyl ion. So its acidity is 1. Properties of acids and bases. Physical properties of acids. Dilute solution of acids have sour taste. For instance, unripe fruits. Dilute acids return blue litmus paper to red. Only concentrated strong acids are corrosive. They burn the skin. In aqueous solution, they conduct electricity. Let's look at physical properties of alkalis. Dilute solution of alkalis have bitter taste, and dilute alkali will turn red litmus paper to blue. Don't forget that only concentrated strong alkalis are corrosive, and they have a slippery feel or soapy feel. Chemical properties of acid. Metals will react with acid to form metallic salts and hydrogen gas. For instance, zinc is a metal. When it reacts with acid, it will produce zinc chloride, which is a salt, a nitrogen gas. Bases and alkalis react with acid to produce metallic salt and water. This process is called neutralization. For instance, sodium hydroxide and hydrochloric acid will give us sodium chloride, which is a salt, and water. Dilute acid will react with metallic sodium triazocarbonate 4 to form other metallic salts, water, and carbon 4 oxide, as illustrated in the equation below. Chemical properties of alkalis. Ammonium salt, if warmed with an alkali in the presence of water, give us ammonia gas. So sodium hydroxide reacting with ammonium chloride. Sodium hydroxide is a base. Ammonium chloride is an ammonium salt. When they react, they give us sodium chloride, which is a salt, water, and ammonia gas is released. Bases and alkali will react with acid to produce metallic salts and water. This process is called neutralization. So acids and base. Sodium hydroxide is a base reacting with an acid, which is hydrochloric acid, to give us a salt, sodium chloride, and water. Dilute acid will react with sodium triazocarbonate 4 to form other metallic salts, water, and carbon 4 oxide, as illustrated below. Sodium triazocarbonate 4 and an acid will give us sodium chloride, water, and carbon 4 oxide. Now, let's look at how we can prepare acids. Acids can be prepared by 1. Dissolving acid anhydride in water. 2. Direct combination. 3. Displacement. 4. Precipitation. But 1. Acid anhydride are oxides of non-metals which will react to form corresponding acids. Example of acids anhydride: carbon 4 oxide, sulfur 4 oxide, sulfur 6 oxide, and nitrogen 4 oxide. For instance, if we make use of carbon 4 oxide reacting with water, we are going to get triazocarbonate 4 acid. Also, if we make use of sulfur 6 oxide to react with water, we are going to get an acid, which is tetraoxosulfate 6 acid. Through direct combination, hydrogen can react with non-metals such as chlorine and bromine to form an acid. For instance, hydrogen reacting with chlorine gives us hydrogen chloride, or hydrogen reacting with bromine will give us hydrogen bromide gas, which are acidic gases. A stronger acid can displace the weaker one. This is called displacement. So, the stronger acids are hydrogen chloride, triazonitrate 5, and tetraoxosulfate 6. So, tetraoxosulfate 6 is more acidic than hydrogen chloride and than triazonitrate 5. So, sodium chloride is a salt of hydrogen chloride gas. In fact, sodium chloride is gotten from hydrochloric acid. So, when it reacts with tetraoxosulfate 6 acid, which is a stronger acid, we're going to get hydrochloric acid as one of the products, as well as a salt, which is sodium hydrogen tetraoxosulfate 6 salt. Through precipitation, a soluble sulfide of metal from a solution of metallic salt can actually form hydrogen sulfide gas. Looking at this, copper trioxonitrate 5, when it reacts with hydrogen sulfide, we can get an acid, which is the trioxonitrate 5 acid, HNO3. Let's look at the concept of neutralization. Neutralization reaction can be defined in two major ways. One, in terms of acid and base present, and we can define it in terms of hydrogen ion and hydroxyl ion present in the acid and base. For instance, Let's start with the first one. In terms of acid and the base, neutralization can be defined as a process whereby an acid reacts completely with an alkali or bases to form salt and water. For instance, hydrochloric acid, when it reacts with sodium hydroxide, hydrochloric acid is an acid, sodium hydroxide is a base. We're going to get salt, which is sodium chloride, and water. In number 2, if we make use of the second terms, then neutralization can be defined as the combination of hydrogen ion and hydroxide ion to form water molecules, and a salt is also formed at the same time. Let's make use of hydrogen ion alone and hydroxyl ion. We have this. You can see that water will be formed. These two concepts can be used to define neutralization. Let's look at this little experiment. How to produce an acid using sulfur solid. What we need to do is we put our solid, which is sulfur, inside a boiling tube. This boiling tube is used to boil the sulfur in order for us to get sulfur dioxide, SO2. Then we connect a valve to the boiling tube so that when we boil the solid, which is sulfur solid, it can release sulfur dioxide for us. In the second setup here, we add hydrogen peroxide to the container. Hydrogen peroxide is the one that will react with the sulfur dioxide gas to produce sulfuric acid for us. Now, we are now going to go ahead and connect the valve together. Now, we will start heating up the sulfur solid in the boiling tube so that we can get our sulfur dioxide. Remember, what we need is sulfur dioxide to react with hydrogen peroxide. As we boil the sulfur solid, the heat will cause a gas to evolve, and that gas is sulfur dioxide you are seeing here. This sulfur dioxide will react with the hydrogen peroxide there to form an acid. We need more sulfur dioxide. Let's keep heating. Now we are through heating. We can disconnect the connections. Our hydrogen peroxide is no more hydrogen peroxide now. It is now a sulfuric acid because of sulfur dioxide that has reacted with it. Let's see whether it is truly an acid by carrying out a test. This test we want to carry out is called litmus test. In litmus test, what we need to make use of is only a paper called litmus paper. For litmus test, if the litmus paper you are seeing right now, the blue changes to red, then it is an acid. So we can see the blue paper turns out to be red, therefore it is an acid. So when we burn sulfur dioxide is produced. Now, if it dissolves in hydrogen peroxide, it will produce sulfuric acid. This is the equation for the reaction: sulfur and hydrogen peroxide. And this is the symbol you're seeing here. So, now we can go on and make the sulfuric acid to become concentrated by heating. Heating it will remove excess water, and the acid will become a concentrated sulfuric acid. You will see water vapor coming out. Of course, you're already seeing that. This is a concentrated H2SO4. This is a simple experiment that can only be performed in the laboratory. Please subscribe to my channels on YouTube. Now, let's go on and see some uses of an acid. In fact, I want you to do this by yourself. Find out the uses of the following acids and base: hydrochloric acid, triazosulfate 6 acid, triazonitrate 5 acid, ethanoic acid, lactic acid, and these bases. Ethanoic acid, don't forget. So for the bases, sodium hydroxide, calcium hydroxide, potassium hydroxide, and ammonia and ammonium hydroxide. So this assignment I've just given to you before the summary, please make sure you submit it on Edmodo app. Summary. Here we have learned that an acid is a substance which, when dissolved in water, will produce hydrogen ion. And these are the other things we also learned today. Thank you for watching. Please make sure you download the notes on pH and pOH attached to this video. Thank you. I hope to see you soon. Bye.
Thank you for watching this video. Now you can go ahead and take the quiz.